Now let us see how many circles will pass through given set of points, right? I will show you that if I have say 1 point, if I have 2 points, or if I have 3 points, how many circles can we make pass through those points? Let us start with the basic thing. Say I have 1 point, just a point given, and if I'll ask you, can you tell me how many circles will pass through this point? Obvious answer, infinite number of circles. Agree? Say I can draw a circle like this, I can draw a circle like this, or maybe like this, and many circles can be drawn through this 1 point. So one thing is clear, that if I have just 1 point, infinite number of circles can be drawn such that those circles pass through the given point. Now if I'll ask you, let us take the second case. If I have 2 points, two given points, then how many number of circles will pass through it? Say 1 point is here and 1 point is here. Now tell me how many circles will pass through it. Just think of it. Many of you may have just one, that you may say that only one circle can pass through it, or two circles can pass through it, or three circles can pass through it. So can you give me a number? Let us try to draw it. Say I have a circle like this that passes through it, right? In which this, if you'll join them, you'll get a chord. Or there can be a possibility that you have a circle like this, or a circle in which this can act as another chord like this, or maybe like this. Similarly, you can have a circle like this, right? With the length of the chord, this, now see, this is a length PQ, right? When I'll join both the points, I'll get a chord PQ. Now this can be a chord of many circles, right? If I have a circle here, this PQ can be a chord here. If I have another circle here, this PQ of different radius obviously, then this PQ will lie somewhere here. The chord being the same, but the circles will be different. That is why we'll again get infinite number of circles passing through two given points, right? Maybe like this. Sometimes PQ can act as the diameter as well, sometimes it will act as the smallest chord, or sometimes it will act as a normal chord, depending upon what the radius of the circle is. But in short, the thing is, infinite number of circles can pass through two given two given points. Now let us take the third case. What will happen when you have three non-collinear points? Three non-collinear points. In that case, can you tell me how many circles can pass through it? Say 1 point is here, 1 point is somewhat here, another point is here. Say I have three non-collinear points, and I want to know that how many circles can pass through it. Well, normally you can obviously just look at it and say that only one circle can pass through it, right? Say, and let us see how one circle or two circles or three circles, let us see how it is possible. So what I'll do here, I'll join these points. I'll join this and this. Let me call this A, let me call this B, and let this point be C. So I'll join AB and BC, right? So I got two straight lines, right? Now what we'll do, we'll draw the perpendicular bisectors of AB and BC. What? We'll be drawing perpendicular bisectors of AB and BC. Well, you easily know how to draw perpendicular bisector. Take an arc greater than half the length of AB, cut it this way, this way. Similarly, put the point on the B and then cut it this way and this ways. The point where they will meet, just join them. This will be the perpendicular bisector of AB. Similarly, if you want to draw the perpendicular bisector of BC, process is simple. Join them and you will get the perpendicular bisector of BC. Right? Both the perpendicular bisectors, let us say that they meet at a point O. Right? Now, can I say that OA is equal to OB? Will OA be equal to OB? Yes, it has to be equal, because every point on the perpendicular bisector of a line segment is equidistant from its endpoints, right? Every point on the perpendicular bisector of a line segment is equidistant always from its endpoints. So we can say that OA is equal to OB. Now similarly, this is the perpendicular bisector of BC, so I can say that OB is equal to OC, right? Combining both the equations, I can say OA is equal to OB is equal to OC. Clear? Now, if I draw a circle taking O as a center and OA as my radius, suppose I draw a circle with O as center and OA as radius, I know that OA is equal to OB is equal to OC, so that circle will also pass through OB and BC, that is point B and C. If I draw a circle passing through O, I know that OA is equal to OB is equal to OC. So that circle will surely pass through B as well as C, right? Because both all three radiuses are equal. Hence, I got one circle which passes through given 3 points, right? Now tell me, if I have two distinct lines, at how many points can they intersect? Obviously, you might be thinking, what a question is this? But yeah, the answer will be only at one point. If I have two distinct lines, they can only intersect at only one point, right? So, I can now say that since there is only one point of intersection of two given lines, so a unique point can pass through the given set of, a unique circle will pass through given set of points. So, if you have 3 points, one and only one circle will pass through given 3 points.